Our ears are an incredible thing. Without them, we wouldn't know about music, or conversation, or what a crunchy leaf sounds like when you step on it. The sounds we take for granted just wouldn't exist. Thankfully, we can hear sounds because of the way our ears work. The human ear is a sound detector. It picks up longitudinal waves, and your brain interprets the vibrations as sound. There are many different parts of the ear that contribute to hearing. First, there's the pinna and the ear canal. These make up the outer ear. The pinna is the only visible part of the ear, and it funnels the sound through the ear canal to the eardrum. The eardrum, hammer, stirrup, and anvil make up the middle ear. This is an air-filled cavity that is connected to the mouth by the eustachian tube, which allows the pressure of the cavity to be equalized. The eardrum is a tightly stretched membrane that converts the longitudinal waves to vibrations. Compressions in the longitudinal wave cause the eardrum to move inward, and rarefactions move it outward. That way, the eardrum vibrates at the same frequency as the wave. The hammer, anvil, and stirrup are tiny bones that also vibrate at the same frequency. They amplify the vibrations and enhance our hearing abilities. Additionally, the stirrup is connected to the inner ear, and its vibrations create a compression wave in the fluid of the inner ear. The inner ear itself consists of the cochlea, semicircular tubes, and the auditory nerve. The fluid and nerve cells in the semicircular tubes help with balance regulation. This is why your balance gets messed up when you get an inner ear infection. The critical part of our hearing also takes place in the inner ear, specifically in the cochlea. The inner surface of the cochlea is lined with about 20,000 hair-like nerve cells. Each cell has a frequency at which it naturally resonates. When the longitudinal wave moves through the hammer and into the cochlea, the nerve cells that match the frequency of the wave will vibrate with a bigger amplitude. The larger amplitude causes the nerve cell to send an electrical impulse up the auditory nerve to the brain. In a process that is not completely understood, the brain interprets the impulse as sound. So how much can humans actually hear? The threshold of human hearing in terms of sound intensity is about 2.5 times 10 to the negative 12 watts per meter squared. However, to keep things convenient, we generally say that the threshold is 10 to the negative 12 watts per meter squared, which translates to roughly 0 decibels. Now this is a measure of loudness. 10 to the negative 12 watts per meter squared is the quietest sound we can hear. In terms of pitch, humans can generally hear sounds between frequencies of 20 to 20,000 Hz, although there is a notable loss of hearing in higher frequencies among older individuals. This and other variations of hearing loss are often caused by overexposure to noise, which leads to the hair-like nerve cells of the inner ear being flattened. When they're flat, they can't vibrate against the sound waves anymore, and then hearing is lost. There are other reasons for hearing loss like genetics, aging, and ototoxicity, but we'll leave that for another time. Another thing about sound intensity and frequencies is that the lower the frequency is, the louder it has to be in order for you to hear it. Adding to this is the concept of the threshold of pain. This is generally listed as 130 decibels, or 10 quadrillion times the threshold of hearing. However, young people are more tolerant of this level of intensity due to their eardrums being more capable of adjusting to the loudness. Basically, the eardrum tightens and pulls the stirrup back, which sends less force to the inner ear. Now, we've established that humans can hear frequencies between 20 to 20,000 Hz, but there's a whole lot of sounds that lie outside our range that other animals can hear and even use. Infrasonics refer to frequencies below 20 Hz. In nature, these sounds are often caused by earthquakes, avalanches, and volcanoes. Ocean storms can often cause infrasounds as well. As humans, we tend to feel these sounds rather than hear them. Our auditory nerve cells can't respond to sounds that low. However, elephants can create these sounds and use them to communicate over long distances. They feel the waves before they hear them because the sound waves travel faster through solids. Whales, rhinos, and cassowary birds also produce very low frequencies as communication. In addition, humans use infrasound monitors to detect avalanches, atmospheric nuclear tests, and other explosions. Like infrasound, humans cannot hear ultrasound, although we do use it for various medical diagnostic tests. Ultrasound is a frequency that is anywhere above 20 kHz. 1 to 20 MHz are used for diagnostics like echocardiograms, which take sound waves and convert them to colors in a video form to look at the heart and blood vessels. In terms of animals, Bats, dolphins and toothed whales, sloths, rats, and certain insects all use ultrasound at a frequency between 20 to 100 kHz for communication and navigation. Bats and dolphins also use it as echolocation, where they send out ultrasonic pulses. Based on the way the sound wave bounces back, they are able to tell if there are any obstacles or food ahead of them. Bats can even tell if their food is good to eat by the way the wave bounces back. Humans can't hear ultrasound or infrasound because our ears simply aren't sensitive enough to hear those very low or very high vibrations. However, there is a very wide range of frequencies and intensities that humans can hear, and we can use machines to detect and utilize ultrasound and infrasound. We are very lucky to have our ears. Thank you for watching The Characteristics of Human Hearing.